Hey you guys, it's me Abdul and I'm back again with another Unity tutorial. This time we're going to get a little further with our Koopa Shell collision and raycast detection. And without further ado, let's hop off to where we last left off. That's a weird phrase. But anyway, so if we go to our prefabs folder, open up our Koopa Shell prefab, go down, go to the Koopa Shell script component, look at the enemy mass. Let's change this to everything. Let's go again to our player, which is not a prefab, which we should change. So let's change this. Mine says player 1. So let's delete this and then delete the inactive. Well, no, we'll keep the active form of our player. So let's keep this. Let's make this. Let's press Control Shift N, make a new game object. We're going to call this raycast and drag this underneath our player to make our player game object the parent of that. And then we're going to go to the transform of the child empty object we just made, reset the transform, go and make a box collider 3D. So it's just going to be a regular box collider, nothing else. Click on it to make sure the wait, let's get this into the click on this to make sure the diameter, or I'm sorry, that's ignorant, beyond ignorant. This would be a circle. This is not a circle, this is a square or a cube, three-dimensional cube in this case. But we want to make sure that our collider is outlined to our player exactly, and that is the case. So from here, let's make this a prefab. So just drag and drop it to our prefabs folder. Go to the inactive player. Copy the transform component. So we're just copying the values of that. Go back to the new player component that the player prefab we just made. Go to the transform component. Go to paste component values. And there we go. That way our player is still where we want it, and we don't have two instances of the player, and we can delete the inactive player. And if your scene is not quite like this, then don't fret. You can either download exactly what you see here on GitHub, or you can just edit it to your liking, or you can just simply play with this in the transform. It's not that big of a deal. It's just me because I have OCD, or I don't have OCD, but I just like to say that I do. But anyway, yeah, there was a couple discrepancies in our script that I didn't really specify. So let's go here and close this extra opening of Microsoft Studios, Visual Studios. Let's go here, go to our script. So the left ray I have here. So this is, I have my trans.transform direction vector2.right, line 62 of our code. This should be vector2.left because this is our left. This is our left ray cast or the left ray that we're casting. So without further ado, let's go here, close this, open up, and we should get our detection now. So let's press play. I'm getting an error for the sprite renderer, but it'll still play. I have been hit on the right side by Unity object raycast. And also another error that we're getting, that's something I'm going to have to fix, is that our player controller script isn't registering us. See, if you go here, our grounded boolean is unchecked and it's false, which is beyond inaccurate, because if you look at it, we're touching the ground, or we should be. So without further ado, I'll fix that in a later episode. Not quite this episode. It is coming. We'll be fixing quite a few things, especially our camera and just basically everything. So yeah, there's a lot of things I've done poorly. But anyway, let's continue on with our script. Yes. So from here, we're going to start with our 3D collision, or continue on with our 3D collision. That is the case. Yep. So void on collision, enter, and collision col with 1L. Let's just make a comment. 3D collision. even though, I mean, we know this, but it may not be obvious to someone. Collision. Open up our curly braces, and voila. Say if. So if our shell collides with a game object that has the tag ground, I was gonna say environment, but ground because, or whatever you have set the kind of the inner environment objects that the player can actually interact with that are on the same Z plane, such as your blocks, your various blocks, whether it be a power-up or a coin or a mystery block or the pipe that we will add. This, it all has to be on the ground tag. Make sure that all your tags are associated with those prefabs. So if you get if this doesn't work and you copy exactly what I've seen, then that could be a problem. Make sure that all your tags are set to that. So this is going to be just like our enemy movement script. Vector3 currot equals up my trans dot Euler angles semicolon currot dot y plus equals 180. Here we go. My trans dot Euler angles equals currot. Debug.log, or you could do print method, and here we're just gonna say this Koopa shell has been flipped in the Y rotational axis. Probably too specific, but hey. So here, if collision between the shell and environment, or yeah, environmental prefabs happen, then the shell is turned around accordingly. And we're doing this based on tags because we don't want this to happen with player collision or enemy collision or a collision with other shells. So yeah, that's all she wrote. So we can test this, but I want to go a little bit further. Let's test this real quick. So control save. Oops. Let's go here. Let's go to our brick block. Duplicate this. Go to transform button. Go here. Drag it down. Oh, that's right. We haven't added any movement. So here, in our shell hit method, what we're gonna do is just add to our constant force, and if you haven't heard me say this enough, I shall spout this once again, that this is probably not the best way to do this. I could simply have used transform dot position with some vector based physics that were being added at every fixed frame or every frame based on what we wanted, but at the time of me writing this script, it just made sense for me to do this, and this is what I did. It's probably not efficient. If you have a better way of doing it, and if it works better, then let me know, or just do it your way and keep to yourself. And yeah, but this is the way that made sense for me to do it, and it's obvious that, you know, yeah, I'm just trying to get something that works. And I more than appreciate any feedback and letting me know how to suck less, because that would be awesome. Anyway, without further ado, let's press on. So CF, because we have shorthanded our constant force component, so we don't have to grab it, equals new vector 2. So if the shell is moving right, then if the shell has been hit from the right side, then we want it to move right. So we want a positive 30. Made this mistake already. So you want a positive 30. Oh, not 300. Positive 30. And we want likewise for the left side. So left side, control paste. Because you know, developers are lazy, so let's be lazy too. I'm just kidding. Let's not do that. So control save. So basically, here we are. Shell gets hit from the left side, then the shell moves to the left. So let's shell is if shell flag Boolean flag goes off, if left hit shell left Boolean flag goes off, returns true, then the shell moves to the left with a constant force. We want to be able to our public boolean that we have defined, the moving boolean, we want to be able to make sure that this sets to true. This is going to be a flag that lets us know if moving is true, then we can damage our player. But at the same time that we at the same time that we initially collide with our player, the player collides with a resting Koopa Shell. We don't want moving to be set to true because the player will be damaged for simply touching and starting the Koopa Shell, which is not idealistic, which is not the way the game is played. So, with that said, what we're going to do is we're going to need to be able to manipulate when moving is set to true, but call it at the same time that collision happens. So the only way to do this that I know of is a enumerator or a coroutine. So coroutine, you can yield a value to be returned at a specific point of time or within a specified time that confirms to, a coroutine's basic rules. So with that, we're going to be able to, it's like a method that makes certain lines of code execute at a certain point that you specify. So with this, we automatically get an error. Why? Because they must return something. You must yield to return something. Implemented model behavior methods so that we can just easily add to our script like that. And since I have a bad habit of pressing collision or mistyping collision, so here we've implemented the method. Let's go to here, put all that stuff up, get rid of this, get rid of these because we no longer need them. Let's change collision to col with 1L. Let's go here, make sure it wasn't my spelling, even though I don't think that was the case, and it's probably still going to be an error, but here we just want to, I don't trust myself, so we do not have what we want. So let's see here, if we move the debug.line up, debug.log, let's see if collision is happening. So let's go to our brick block and make sure that it is So here we have ground. It is under our ground tag. So if it equals the ground, we should get a log regardless. That may not be the case because this is happening on the 3D side of things. And if you look at, if we go here, let's go here, press this, go to Koopa Shell clone, open it up, go to the ray holder, zoom in, and see that our ray holder is not touching the object. So, Koopa Shell, go to edit collider. Let's go to brick block. Second copy. Edit collider. It's very interesting because we need to make a choice. So if we do collision like that, then we will have a problem where if we do collision like that, then we're gonna have a problem of where it won't interact with things on the 2D side of the physics. So let's change this to physics.enter 2D. And let's see if we can keep things 2D. Obviously, we're going to have to make some comments saying here, hey, this is all 3D based, or this is no longer 3D based. So let's go here. That is still not the case. So that is something that I will have to get back to you guys on. The show must go on. So without further ado, I'm going to continue on. We're going to focus on our method of making sure that we know that the shell is moving and how to get it started moving and how to not interfere with the player just yet when it initially starts moving. So with that said, let's go on and I will get back into the collision error, because collision, that same collision error is the basis behind our jumping not working, and we're gonna fix that eventually. So be able to make a note to myself. So here we will stop with the 3D collision. So can do here, and then let's go here, and then just want to make a distinct block of letting people know that, hey, this is where 3D collision ends. Let's copy this, paste, then let's say 2D collision begins. Get rid of that. Oh. So here we are, 2D collision begins. Oh, we probably can uppercase this. This is just me being nitpicky, but hey. Okay, so with that said, so we want to be able to, our public boolean that we have defined, the moving boolean, we want to be able to make sure that this sets to true. This is going to be a flag that lets us know if moving is true, then we can damage our player. But at the same time that we at the same time that we initially collide with our player, the player collides with a resting Koopa Shell. We don't want moving to be set to true because the player will be damaged for simply touching and starting the Koopa Shell, which is not idealistic, which is not the way the game is played. So with that said, what we're going to do is we're going to need to be able to manipulate when moving is set to true, but call it at the same time that collision happens. So the only way to do this that I know of is a enumerator or a coroutine. So coroutine, you can yield a value to be returned at a specific point of time or within a specified time that confirms to, you know, a coroutine's basic rules. So with that, we're going to be able to, it's like a method that makes certain lines of code execute at a certain point that you specify. So with this, we automatically get an error. Why? Because they must return something. You must yield to return something. So basically what we want to do now, so we're going to wait 0.2 of a second and yield return moving to true. Let's go here, void on collision, enter 2D again, or no, just 2D, because we changed the first one back to 3D. Collision 2D, col with 2 L's. Go here, if left blocked, or right blocked. And if the game object dot tag equals player and this shell or this game object or this instance of the script's moving boolean equals false, then what we're going to do is start the coroutine move shell. Let's copy this. But else if, or we don't have to say else if, it's just else, or if moving equals true, we're going to basically want to implement the player damage system that we have with the switch case statement in the player controller. So what we're going to do is switch player controller dot player state, and then define our cases. Case 1, player controller dot player state equals 0. Break. Then we're going to do the same for case 2. So case 2, player state equals 1. Break. And then we have a default. So here, I'm gonna default. Player state equals nothing. And what we're gonna do is destroy col.game object, and in the future we're going to implement lose a life, or we can go ahead and debug.log this to say you just lost a life. We're obviously going to have to implement some method that makes sure that the number of lives still is greater than 0. If not, then there will be a game over that occurs. But for the purposes of this video, this tutorial, we are not quite there yet. But what we want to do is make sure that basically what we have instantiated, or what we have defined in our algorithm of our Koopa Shell's algorithm of checking whether or not the shell is blocked, and if it is blocked, making sure that the collision of the player is detected, as well as this, which is not logical at all. But I just want you guys to see this. This is not logical. What we exactly need. So let's just take out the if statement. Let's have here. This is God ugly. Oh God, that's so ugly. What is this from? Let's go here, shift tab, make this a little prettier, controls stuff. Okay, so basically, on collision, after a quarter of a second, moving should be true. So moving equals true. But that is not what we want, so let's look here. Step into it, step. Koopa Shell, moving equals false, keep going, moving equals true. That's on collision. So what we could do is probably make these, okay, so our left and right block is what are the parameters that we're going to be basing everything off of. So let's make these shorter. We're going to have to make this, the debug.drawLine short as well. So let's go 0.73. Or no, let's just make this 6.7. This will probably help out tremendously. Okay, I am back and I have figured out my quorum. So basically, we want to be able to, when collision no longer exists between the player, so we want the Koopa Shell to move, right? Yes, we want the Koopa Shell to move, even if collision with the players continues to go on. So okay, that's awesome. And but we don't want the player to be damaged until that collision breaks and happens again, while the moving Boolean is true. So with that, we're gonna go to our code and we're gonna look at what I ignorantly wrote. So we're going to have the same coroutine, but we're going to pass in a parameter of our collision2d col. And within our coroutine, now we're going to say if col.gameObject.tag equals our player. Yes, what we've been doing. And if left blocked and right block equal false, then we're going to wait for a 20th of a second, or 200th of a second, and then we're going to 200th of a second, then we're going to yield return equals true. And then based on that, what we're going to do is continue on to our avoid collision, or on collision enter script, which says if left block and right block equals true, and or if one of those equal true, and if the player is colliding with the resting Koopa Shell and moving doesn't equal true, then obviously it's still resting. So we're going to start a coroutine call and pass in our parameter call, which just calls our player again to make sure that we're referring to the same thing. What we could do here is change this wait for seconds to new wait for end of fixed frame, or wait for fixed frame, and that would be perfectly fine. So let's put parentheses here. We could probably say some comments. Let's just see if this works first. So what we're gonna do here is press play. So here we're gonna go and touch our player, and yeah, the shell's moving. We aren't suffering the benefit. We are suffering the repercussions of colliding with our player, and we can now move on. I feel so ignorant because this whole time I could have just passed in the parameter for the collision. But anyway, thank you guys so much for watching. That has been one hell of a tutorial. I had to do this twice and it's been over an hour. This is obviously going to be cut down, but yeah, thank you guys so much for watching. We're still not done yet. We still have the enemy base collision and other Koopa Shells, which is quite a doozy in itself and got me going for a couple weeks. But without further ado, thank you once again. I keep saying thank you. Thank you for watching. If there's anything that you see that I missed or you want to touch on, or if you want to help me fix this collision, please, you feel free, more than welcome to, and thank you in advance. Thank you again. Be sure to save your scripts, save your screen, and save your scene, not screen. And if you want to catch this on GitHub, it will be there. So yeah, thank you guys for watching, and adios. See you guys later.
Bye.